Okay, so a test cross. Like the name indicates, okay, we are testing, we're testing to see what the actual allele combinations are, okay? So it's the cross of an organism of unknown genotype with a homozygous recessive organism, okay? So let's say that we have an unknown tall plant, okay? So we want to find out whether or not this is a big T or a big T little t. Okay, so it can be this in a sense. Okay, so we don't know what that other allele is. So we just know that it's tall. So that big T has to be present. Okay, with a homozygous recessive. Okay, so in our short plants, that means that we have to cross it with the little t. Okay, so let's pretend that we have big T, and let's assume that that's what actually happens, okay? So, in a cross like this is a possibility. Okay, and the reason why we do this test cross, you'll see with the other one, okay? So, if we were to cross this, we do a quick Punnett square, big T, little t is all you can get, okay? So if we don't know what this is, okay, and that was kind of like our unknown, if we were to cross it with a little t, that little t won't actually show up as a possibility, okay? But watch what would happen if we actually have a big T with those little t's that we're going to cross in there, okay? So our Punnett square, and this is the one that you guys are actually going to draw out, okay? The little t goes here, and then our little t, and this is what I'm saying, you can actually kind of shorten this because the little t's are the only possibilities there, but in this type of a cross, we would actually see a short plant show up in the next generation, okay? So this is what's known as a test cross. If we don't know whether or not something's a heterozygous dominant or a homozygous dominant, we will always cross it with some sort of a recessive trait. And if those babies that are made and the recessive trait shows up, that means that it had to be a hybrid in order for that to happen, okay?